In our last lesson, we talked about identifying key features of a graph. Now what we're going to do is interpret the graph of a function and identify key features related to the context of the problem. So we'll be looking at areas where it's increasing and decreasing and talking about what that means. So when a function is increasing, it's getting larger. X increases, Y increases. It has a positive slope. So notice here in the graph, increasing is where it's going up. Decreasing, on the other hand, is where the function is going down. As x increases, y is decreasing, so the slope is negative. I highlighted that in purple. A constant. What does it mean if something is constant? It stays the same. We see a flat line. Remember, graphs are always read from left to right. So as you're going from left to right, notice it's increasing, staying constant, increasing, decreasing. So let's take a look at this first question. Which graph does not represent a function that is always increasing over the interval -2 to 2? So we're looking specifically on the x-axis from -2 to 2. So what I'm going to do is zoom in here and look between the x values -2 and 2. What is the graph doing between -2 and 2? Looks like it's increasing. We're looking for the one that is not always increasing from -2 to 2. So let's take a look at the second option. From -2 to 2, what is that graph doing? So let me see what it's actually doing. We have points here. It is increasing, right? It's going up. So far, they're both increasing between -2 and 2. Now let's take a look here between -2 and 2. Well, what is this graph doing? Increasing. Oh, then notice it starts to decrease. That looks like the answer, but let's just double check over here. What is this graph doing between -2 and 2? I'll highlight what the graph is doing. Increasing. So the only one that is not increasing the entire time is C. Let's take a look at this example here. The graph below represents a jogger's speed during her 20-minute jog around her neighborhood. So take note of where things are increasing, where the graph is going up, where the graph is decreasing, it's going down, and where it's remaining constant, it's a flat line. What is happening over the interval 0 to 2? Notice this says x is somewhere between 0 and 2. X means we're going to look at the x-axis between 0 and 2. So let's hone in here. 0. What's it doing between 0 and 2? Well, there's the x value, 0 and 2. Let's see what our graph is doing between those two. We'll highlight there. Notice, what is the graph doing? The graph is increasing. What does that mean in the context of the problem here? Our speed, how do I know it's speed? Because I'm looking at the graph right here, the title. We're comparing speed and time. So as time increases, our speed is also increasing. What is happening over the interval 2 to 5? So I'll look at my x values between 2 and 5. And let's highlight what the graph is doing there. What is the graph doing? Notice it's a flat line. It's a straight flat line right across. It's horizontal. It is constant. What does that mean? That means the speed is remaining the same. The speed is constant. The speed is not changing. I'll add to number 1, speed is increasing. So we have that written down. So that's, for example, if you're getting on the highway, you're speeding up. That might be what's happening here. And then maybe they're cruising at the same speed on the highway. You're not going 3 miles an hour, but just as an example. What is happening over the interval 12 to 14? Notice this is just another way to write an interval between 12 and 14. So let's highlight that on our x-axis, 12 and 14. What is our graph doing there? What's our graph doing between 12 and 14? The graph is decreasing. Now, what does that mean in the context of this problem? The graph is decreasing. We're talking about speed and time. That means it is slowing down. How do we know? Because our speed is decreasing. Maybe we're getting off the highway here. Again, I don't think we're talking about the highway here because we're talking about miles per hour, but that's my example as far as increasing, decreasing speed remaining the same. Let's take a look at number 4. Which statement best describes what the jogger was doing the 9 through 12 minute interval of her jog? So what will we do first? Let's find 9 through 12 on our x-axis. Why the x-axis? Because that's where minutes are, our time is, between 9 and 12. Well, let's see what's happening on our graph there from 9 to 12. What's happening? Looks like a constant speed to me. So constant speed. Could she be standing still? If she's standing still, will her speed be constant? Was she increasing her speed? Would that mean her speed is constant? Was she decreasing her speed? Would that give us a constant speed? Or was she jogging at a constant rate? She would be jogging at a constant rate. That's the only one where the speed remains the same. She's not standing still. That would mean that she would have a speed of 0. Our speed isn't 0. It's just a constant flat line. Let's take a look at the practice problem. John left his home and walked 3 blocks to his school as shown in the accompanying graph. What is occurring between points A and B? So we notice, is it increasing, decreasing, or constant? The graph is increasing. But what does that mean? How do we figure out what that actually means? Let's look at the labels of the axes. We are comparing distance, time, and distance. So as time increases, distance is increasing. So what does that mean? As time increases, here his distance is increasing. That means as time goes on, he's getting further from his home. What is occurring between points B and C? B and C, what's happening on the graph? Increasing, decreasing, or constant? I notice that's a constant. It's not increasing nor decreasing. And we're comparing distance and time. That means the distance is staying the same. It's staying at 2. So what would that mean if the distance is not changing? That means for that time, however long that is, he's not moving. So maybe he stopped for a break. Maybe he stopped to chat, but he's not moving from B to C. What is occurring from between points C and D? Oops. The graph is increasing. And again, what does that mean in the context of the problem? Remember, we're comparing distance and time. So the distance is increasing as time increases. So again, he's getting further from home. What is one possible interpretation of this section of the graph from points B and C? So we're looking back at this green segment here. And remember, we talked about that. That is a constant right there. The distance is not changing. So John arrived at school and stayed throughout the day. Would that mean his distance from home isn't changing? John waited before crossing a busy street. John returned home to get his math homework. Or John reached the top of a hill and began walking on level ground. So one I want to rule out here is that John reached the top of the hill and began walking on level ground. If he's walking on level ground, his distance will still be increasing. you may think he's walking on level ground because the line is level, but that doesn't mean he's walking on level ground. That just means his distance is staying the same. If he's walking at the top of the hill and still walking, his distance is increasing still. John returned home to get his math homework. How do we know that that's not it? Well, if we look at the graph, John's distance from home is always getting further. He's never getting closer to home. We don't see a decrease in the distance. So he never went closer or back to home. So we can cross that off. And now we're stuck between A and B. John arrived at school and stayed throughout the day, or John waited before crossing a busy street. Now, both of these are where John is staying at one place the entire time, right? However, I'm going to infer here that he, after school, would probably go back home. So if this were a graph where he were staying at school here and going back home, I might see the graph decrease. I also notice that the segment that's constant, B to C, is smaller than the amount of time it took him to get there, this AB segment. So that means he spent more time walking here than he did here. I don't think he'd spend more time walking to school than he did at school. So I'm going to cross off option A, which means that that segment B to C is where John waited before crossing a busy street. He didn't wait too long. If you were waiting at school, that'd be a much longer line, right? Because it would cover more time. So remember, when you're looking at a graph, whether it's increasing, decreasing, or constant, you want to identify that, but then think, what does that mean in the context of the problem? And your labels of the axes are so important in telling you what it actually means. So use those to help you determine what's happening in the context of the problem.